it'll be simplified if under the square root there are no other perfect square factors other than 1. If under the square root there is no fraction. And if there are no radicals, no square root signs in the denominator. Okay, here's how we do it. What you're going to do is you are always, if you want to make a note out to the side, because I didn't write out steps for you, you need to find the largest perfect square that you can divide by evenly. So you cannot divide and get a decimal. Has to be, when you divide, you get a perfect number. So we want the largest. That's important because it makes your life a lot easier. So a lot of these we'll be able to divide by 4. If that's not the largest number, then don't use that one. If you want to make a list out to the side, when we're talking about perfect squares, we are talking about these ones. 1, 4, 9, 16, 25, 36, etc., right? Those are the numbers we're looking for. And we want the largest one that number can divide by. So the square root of 45 can be broken up. Think about your list of perfect squares. 1, 4, 9, 16. They're on that poster over there, underlined in green. What's the largest perfect square that 45 evenly divides by? You can go through the list if you want. We don't care about 1 because 1 doesn't count. Does it divide evenly by 4? No. Does it divide evenly by 9? Yes. Okay. Hang on to that. Does it divide evenly by 16? Nope. By 25? By 36. Obviously, everything above that is not going to work because it's larger. So what's the largest perfect square this divides by? 9. So we are going to now rewrite this as 9. 9 times what? 5. And put that perfect square in the front. Because what we can do is now break this up. This breaks up into the square root of 9 times the square root of 5. And what's the square root of 9? 3. So this is simplified when it's written like this. This is your simplified answer. 3 root 5. That's how we say that. So when we talk about simplifying radicals, that's what you do. You break it up so that it's multiplied by a perfect square. Take the square root of that perfect square. This is simplified. This is a way to write your answer instead of a decimal. So you find the largest number, break it up, simplify. Go to the next one. Square root of 200. Look at your list of perfect squares underlined in green on the poster, or just think about them. 4, 9, 16, 25, etc. Talk amongst yourselves. What's the largest one that 200 divides by? Okay, what's the greatest one? It divides by 25. Is there a bigger perfect square? What is it, Kayla? 100. So 25 is good, and if you only thought of 25, it would still work. You could just keep going. But it actually does divide by 100, and so we're going to use that one because it's the largest perfect square. So we rewrite this as 100 times what? 2. Okay? So this is the square root of 100 times the square root of 2. And what's the square root of 100? 10. And you can use the front of your notes to help you if you need. The square root of 100 is 10, so we write the final answer as 10 root 2. Check your square root. 2 cannot divide by any other perfect square besides 1, and so you are done. So this is simplified. You're good. Okay. One more. Look at the next one. You've got square root of 50. Think through your perfect squares, 4, 9, 16, etc. What's the largest one that 50 divides by? Okay, and so that can be written as the square root of 25 times the square root of 2. So if I ask you for simplest radical form, you're doing this. What's the square root of 25? 5. So your final answer is 5 root 2. Check it. Does 2 divide by any other perfect squares besides 1? No. So you're done. That's simplified. Square. So when we're talking about variables, if the exponent is even, an even number, it's a perfect square. So you would have to think about what times itself gives me that. So x squared is a perfect square. Guys, what times what gives me x squared? X times x, right? X to the first times x to the first. So this is just equal to x. Because x to the first times x to the first equals x squared. So you'll have to cut it in half. This is x to the first. If you wanted to put a 1, you could. Next one is g to the fourth. That's a perfect square. So what's the square root of g to the fourth? G to the second, because g squared times g squared equals g to the fourth. You're having it. Okay, but you can't take half if it's an odd number. You have to break it up. So the largest perfect square that divides by would be x to the sixth. So we want to split it up like this. X to the sixth times x to the first. And you can write that in separate square roots. What is the square root of x to the sixth? X to the third, because x to the third times x to the third, you add your exponents, gives you x to the sixth. So you leave the one that has an odd number in this square root. Yes. You can write it with the first or not. Didn't matter. No worries.
Thank you.
So that would be simplified. Okay. And then the last three are combinations. So you have to simplify the number and the exponent. Okay, sometimes you'll have a perfect square already, and so it makes it kind of easy. Square root of 25 is what? Guys, what's the square root of 25? 5. So let's make it simpler right off the bat. Let's write that as 5 times the square root of v to the fifth. That makes it a little bit easier. Okay, v to the fifth is not a perfect square, but what's the highest perfect square that you could break it up into? V to the what? V to the fourth. So we're going to split this up into v to the fourth times v to the first, which you can write as separate square roots if you want, like this. Okay, and what's v to the fourth? Or square root of v to the fourth? V to the second. So 5v to the second. And you could put v to the first, or you can just put v, since that is just one v. Okay. These next ones are awesome. Love it. 18. Let's deal with that first. Can you please discuss what's the highest perfect square that 18 can divide by? We're going to split this up into 9 times 2. Okay. X to the fourth, is that a perfect square? Yes. Okay, we're going to leave that. And then y to the third, is that a perfect square? No. So what would I want to break it up into? Y to the second times y to the first. I know it's a lot. Here's what we're going to do. We're going to put the perfect squares in one and everything else in the other. So your perfect squares are the 9, x to the fourth, and y to the second. We're going to put those in one square root and everything else in the other. So y to the second will go in this one. And then everything else that's not a perfect square will go over here. 2y to the first. Because we got to take the square root of the stuff on the left. What's the square root of 9? 3. What's the square root of x to the fourth? X to the second. And how about y squared? Just y to the first, or y. And then left in your parentheses, you still have this. You can't do anything else with that. So you would be done.